me see. Okay. Hi, everyone. Good morning. So today is Wednesday, January 31st. So today we're going to start session 7.3. Have you printed out the 7.3 worksheets? Good. Okay. So our second homework and on 7.2 and 7.3 is going to do on next Monday. And we also have quiz 1. Yes. Quiz 1 is going to be about 7.1 to 7.3. Okay. So let's see. Today we're going to work on 7.3. So 7.3, the unit circle, and 7.4, the other trig functions. Okay. So I just give you back this worksheet, right? You fill with opposite, hypotenuse, and adjacent. And this one, you fill with x, y, and r. And this picture is when the angle is in the first quadrant, right? But if we look at the whole entire xy plane, the angle could be on the second quadrant, or third quadrant, or fourth quadrant. Okay, everybody? But the relations, they are all the same. Okay, all of these, they're all the same. It's just we allow x to be negative, and we allow y to be negative. You can pick up your the worksheets from last time. Okay, so let's look at this. Okay. All right, so sine. Sine is opposite over hypotenuse. So opposite of the angle. So if you're not familiar with this picture, feel free to draw a picture in the first quadrant. Because in the first quadrant, the x and y are positive, so it's easier to see, right? If you don't like that picture, you can draw another one, and you know that's x, that's the y, and that's the r, and that's the angle theta. Therefore, sine, opposite over hypotenuse. Opposite is y, hypotenuse is r, right, everybody? And cosine is adjacent over hypotenuse. Yes. Feel free to pick up the worksheets. If you don't get it 100% correctly, please come to my office to pick another one. So I'm available from 11 to 1:50 p.m. and 3:10 to 5 p.m. Okay, so if you don't get them perfectly, then you can come to my office and practice another one. All right, and tangent. Tangent is opposite over adjacent, therefore y over x. Hi, Zach, you can pick up this. And cotangent is 1 over tangent, so flip them, right? Secant is 1 over cosine. Some of you put 1 over sine. No, it's 1 over cosine. So we put the cosine. And cosecant is 1 over sine. So that's why you put the y and r. Okay, everybody? All right. So now we allow the angle to be in second quadrant. Okay, look at second quadrant. Your x is positive or negative? Negative. Your y is positive or negative? Positive. And then how about the third quadrant? Your x is negative, your y is negative. How about the fourth quadrant? X is positive, y is negative. Yes. Okay, very good. And then the trig identities. Okay, so last time I tell you there are 3 diagonals. Okay, for the diagonal, we have the product of the two ends equals the middle one. Yes, do you still remember? Okay. Now, today we talk about the triangle formula. Do you see in this picture there are three upside down triangles? I call them upside down triangle because usually when you draw a triangle, you draw like this. Okay, but these three triangles, they're upside down, right? It's point down. So there are three upside down triangles. And the rule is, let me get a red color. The rule is A, B, C. A squared plus B squared equal to C squared. So you see this upside down triangle. The sum of the upper two vertex square equals the bottom vertex square. Okay, everybody? So that's the rule. The hexagon just help us to memorize those trig identities. Okay? Be careful. This is not the Pythagorean theorem. Pythagorean theorem tells us that the sides of a right triangle, right? A squared plus B squared is the hypotenuse square. Okay? But this is not Pythagorean theorem. It's just a diagram help us to memorize the formula. Okay? So, if we look at this triangle, what do you see? Sine square plus cosine square is 1 square is 1. Right? So write it down. Sine theta square plus cosine theta square equals 1. Yes, everybody? So draw the hexagon, then it helps you to memorize the formula. So for those of you who just came, okay, Cecilia, Joe, Julian, and Camilo, yeah, come here and pick up. Yes. Yeah, if you don't get them all correct, I'm in my office from 11 to 1:50 and 3:10 to 5 p.m. today. So feel free to come to my office and practice this. So yeah, now you can fill this out. This triangle, we know sine squared plus cosine squared equals 1. How about this triangle? Very good. Tangent theta squared plus 1 is secant theta squared. Yes, everybody? How about this one? Yes. So cotangent theta squared plus 1 equals cosecant theta squared. We have the diagonal formula and the triangle formula. Is that okay, everybody? Okay, so why? Why do we get those formula? How do we prove that? Okay, so that's not in your initial. Thank you. So we just show one as example. Why do we have these? Okay. Do you remember sine theta in terms of x, y, r? What over what? Sine theta. Y over r, exactly. So let's show this. So we have y over r. That's sine theta. But now we have sine theta squared. Plus, what's cosine theta? X over r. And we have square. Yes, everybody? Now, what does that mean? Okay, so we have y squared over r squared plus x squared over r squared. Right? You can distribute the square, right? Now, do you see the denominators the same? So we can combine them. Denominator is r squared, and we have y squared plus x squared on the numerator. Yeah? Okay, what do you see? Pythagorean theorem. Now it's really Pythagorean theorem. X squared plus y squared is r squared. Yeah, everybody? So therefore, we have r squared over r squared, which is 1. Okay? So this is how we prove the triangular formula. You do the same thing. So you plug in x, y, r, and then you can show the rest. That's the idea. Any questions? Okay. All right. So we take care of this is also called reciprocal identity because now cotangent times tangent is 1. Therefore, cotangent is 1 over tangent. Right, everybody? And secant times cosine is 1. So secant is 1 over cosine. And cosecant times sine is 1. So cosecant is 1 over sine. So this is also called reciprocal identities. And the triangle formula is also called Pythagorean identity because remember how we prove them? We're using the Pythagorean theorem, right? So this is also called Pythagorean identities. Okay, so also we have the quotient identity. Remember what is tangent? Tangent is in terms of x, y, r. Thank you. What over what? Tangent. Y over x. So y over x. And what is sine? Y over r. Cosine? X over r. Do you see y over r? When you divide it by a number, it's the same as multiply by its reciprocal. What is the reciprocal? R over x. Do you see the r cancel, so you get y over x? So tangent is sine over cosine. Keep that in mind. And remember, cotangent is the reciprocal of tangent. So you flip it, you get cosine over sine. Okay? So remember the hexagon, it helps you to remember the diagonal formula and the triangle formula. And remember one more. The tangent is sine over cosine. Then we're good. These are all the trait identities. Any questions so far? So make sure you memorize them. So every day we learn more formula and you're gonna memorize them. So yeah, these ones are the very basic ones you're gonna memorize. Later on this course, we would learn like harder formula. For the harder formula, I will give to you. So I already make all the practice exams. So you can use the practice exam as a study guide to prepare for the exam. And this is the chapter 7 formula sheet. It's blank. And this one with the answers. Okay, so kind of know what formula you need to know before you take the exam. Okay, and this is the final formula sheet with answers. Okay. So you can see these are the ones you need to know. So they are blank. You need to know. These are the ones that you don't need to memorize. Okay? So the math department, we talk about what is really, really important for you. You need to know. Then you need to memorize. These ones, you just need to know how to use them. You don't need to memorize. Okay? So, right. So, and then these ones, you're gonna need to memorize. Okay? So, just follow the instructions and I will try to find some way to help you memorize. Like this hexagon. Okay, the hexagon, you draw it, you look at the diagonal, look at the triangles, then you can memorize it. All right. So let's continue. Okay, so practice. Let theta be an acute angle such that sine theta is 0.6. Find the value of the following. Okay. So we want to draw the picture. Okay, so acute angle means it's in quadrant 1. Right, everybody? Acute angle is in quadrant 1. So let's draw a picture. Okay, we draw a picture. The angle is in quadrant 1. So this is the theta. That's the x. That's the y. And we have, this is the horizontal distance. That's the x. And this is the vertical distance. That's the y. And the hypotenuse is the r. Okay, everybody? We know sine theta is 0.6. Do you know 0.6 is like 6 over 10? Yeah? Let's make the number more pretty. 6 over 10 is the same as what? 3, 5. Yes, everybody? So sine theta is 3 over 5. Okay, tell me what is sine theta in terms of x, y, r. I know you practice a lot. So say y over r. Yeah, say it loud. Y over r. Now you can compare. Because in the first product, our x is positive and the y is positive. Right? Now we can let y to be 3 and let r to be 5. So we let y to be 3 and we let r to be 5. Is that okay, everybody? Mm-hmm. And in this right triangle, by the Pythagorean theorem, we have x squared plus y squared equals r squared. Now we know y and we know r. We want to find x. Yes, everybody? We want to find x. How do you solve for x? We move the y squared to the other side, right? So x squared equals r squared minus y squared. So x equals plus or minus. Whenever you take square root, you have plus or minus. Okay, so plus or minus square root. What is r? 5. So we have 5 squared minus 3 squared. What is 5 squared? 25. What is 3 squared? 9. What is 25 minus 9? Yes. What is square root of 16? 4. Yes. So we get x is plus or minus 4. Now, because theta is in the first quadrant. Okay, so theta is in quadrant 1. Then we know x is positive. Remember 4 quadrants? 1, 2, 3, 4. Quadrant 1, x is positive, and y is also positive. Yes, so we pick the positive 4. Okay, so x equals positive 4. Right, everybody? Okay, so now what is cosine? So cosine theta is in terms of x, y, r. Questions? Yeah, x over r. Very good. So x over r, what is x? 4. What is r? 5. Yes. Now what is tangent theta? X, Y, R? Y over X. What is Y? Yeah, 3 over 4. What is secant theta? Yeah, reciprocal. Right, reciprocal of cosine, which is 5 over 4. How about cosecant theta? It's the reciprocal of sine, which is 5 over 3. Yes. One more. Cotangent. What's cotangent? Reciprocal of tangent. So 4 over 3. Yes, everybody? Mm-hmm. So, right. This is how you can find. So the rule is simplify the sign. So 0.6, you can simplify the 3 over 5. Okay. But if you have like a 0.7, then you just put a 7 over 10. Okay? And then you can look at this one. So if the problem gives you sine theta, then you have y over r. So if the problem gives you some other things, then you look at the ratio to set the different x or y or r. So that's the method. Everybody clear? Mm-hmm. All right. So let's continue. Okay, so find tangent theta, given that cotangent theta is 4. Okay. What's the tangent theta in terms of cotangent theta? Yeah, it's the reciprocal of cotangent theta. So what's the answer? 1 over 4. And that's it. This problem is easy. It's just the reciprocal. But if it asks other trig function, then you have to do these ways. And cotangent, cotangent is what? X over y. Yeah? X over y. So you can set x equals to 4. And so cotangent is x over y. So you can set x equals 4 and y equals 1. Because 4 is like 4 over 1. So if the problem asks you to find all the other trig functions, you set x equals to 4 and y equals to 1, and then you can find the r. Okay, everybody? Mm-hmm. And then you can find all the 6 trig functions. Okay, continue. Find secant if you know cosine. What is secant in terms of cosine? Reciprocal. Right, everybody? So secant theta is reciprocal of cosine. So flip them, we get negative square root of 20 over 2. Oh, by the way, can we simplify them? What is square root of 20? 20 is 4 times 5, right? What's square root of 4? 2. So this is actually square root of 4 is 2. Square root of 5 is square root of 5. And when you divide it by 2, what happens? Yes. So we have square root of 5 negative. Right, everybody? Okay, keep going. What is sine theta in terms of cosecant? Reciprocal. Yes, everybody? Sine theta is the reciprocal of cosecant. Is everybody okay with that? Mm-hmm. So yeah, it requires you to be familiar with the formula. Yeah, so practice. So the reciprocal of 12 over 5 is 5 over 12. Everybody? Hmm. Okay, number 5. Simplify. So usually if the problem asks you to simplify some trig functions, what does that mean? One way is you can express in terms of sine and cosine. We're more familiar with sine and cosine. And all the other trig functions can be expressed in terms of sine and cosine. So idea express in terms of sine and cosine. Oh, so here is using t, then we use t. Okay, so how do we express in terms of sine and cosine? What is tangent in terms of sine and cosine? Sine over cosine. What's cotangent in terms of sine and cosine? Cosine over sine. What is secant in terms of sine and cosine? 1 over cosine. What's cosecant in terms of sine and cosine? 1 over sine. Exactly. See, all the trig functions can be expressed in terms of sine or cosine. So if the problem asks you to simplify, change them, express them in terms of sine and cosine. Okay, so we have secant. What is secant? 1 over cosine over tangent. What is tangent? Yeah, sine over cosine. Bless you. Yeah, so we flip it over. 1 over cosine, when you divide it by a number, is the same as multiply by its reciprocal. The reciprocal is cosine t over sine t. Yes? Is everybody okay with that? Oh, what happened? The cosine cancel. We get 1 over sine t, which is cosecant t. Yes. So we express in terms of sine and cosine, and then we cancel and simplify and see what's left. 1 over sine is cosecant. Yes, everybody? All right. So the next problem, cosine t is 12 over 13. Okay, everybody try to do this problem using the method of the first one. Okay, what is cosine in terms of x, y, r? And now your t, your angle is in the fourth quadrant. So when you draw the picture, the angle is in the fourth quadrant. So everybody try that problem. Yes, yes, yes. You're welcome. Yeah, you're good. So this is y squared, right? And your y is plus or minus square root of and then it's quadrant 4. So draw the picture. Quadrant 4, so your y is positive or negative. Yes. So you take yeah, oh, okay. And then you, yeah, also right now because it's not y is negative. So we make the all right, let's check our answers together. So, answers. Uh, and let's see, it's here. Okay, so we draw the picture. The picture is like this. Maybe I should draw it bigger. This is x, that's the y. We're in quadrant 4, right? Cosine t. By the way, the angle, you can call it theta, you can call it t, you can call it x, you can call it alpha, beta. So that's the angle. Okay, so cosine t is x over r. And now it's 12 over 13. So by comparison, we can let x to be 12 and let r to be 13. And the Pythagorean theorem, x squared plus y squared equals r squared. We want to find y. Yes, everybody? So y would be move the x squared to the right and then take square root. but whenever you take square root, you get plus or minus. Yes, so plus or minus, do you all get plus or minus 5? Yes? And because we're in quadrant 4, therefore the y is negative, so we pick the negative. So y is negative 5. Then, what is sign? Y over r. What is y? Negative 5 over r, 13. Yes? So once you get x, y, r, you can find all the trig functions. Tangent, y over x. Y is negative 5, x is 12. Secant, 1 over cosine. We were given cosine, so just put the cosine, 13 over 12. Cosecant, 1 over sine. Put the sine, so negative 13 over 5. Cotangent, 1 over tangent. So flip the tangent. You get negative 12 over 5. Is that okay, everybody? So here, we have seen the problem that I give you sine, and if I give you sine, you know the y and r, you find the x. This problem, I give you cosine, so you know the x and r, and you find the y, okay? What if I give you tangent? If I give you tangent, then you know the y and x. You want to find the r, okay? So you see here, when we find the x or y, we get plus or minus square roots. But when you find the r, your r is always positive. So when you find the r, do you need plus or minus square roots? No, only positive square roots. Is that clear, everybody? The r is always positive. I mean, if the point is not in the origin, then your r is positive. If your point is at the origin, then your r is 0. Okay, but r is not negative. Okay. So, any questions about this problem? All good? All right, let's continue. Okay. Unit circle. So now how about when the r is 1? Okay, when the r is 1, we have, this is the x and this is the y. And because the r is 1, we get y equals sine theta. Why do I change to s? Okay, sine theta is y. And then the cosine theta is the x. Because r is 1, we get x is cosine theta. And next, tangent theta. Tangent theta is y over x. Cotangent theta is x over y. And secant theta is now 1 over cosine, so that's 1 over x. Cosecant theta is now 1 over sine theta, which is 1 over y. So this is the unit circle. All right, so that's the unit circle. And now the unit circle is very important. We can fill with all the standards. Okay, so let's practice filling out the unit circle. So last class, we talked about 0 degree and the multiple of 30 degrees. Do you remember, everybody, multiple of 30 degrees? And then we also talked about the multiple of 45 degrees. Yes, everybody? So we first figure out the angle. This is 30 degrees, 60 degrees, 90 degrees, and then 120 degrees, 150 degrees, 180 degrees, 210, 240, 270, 300, and 330, and 360 degrees. Do you still remember when we figure out the angle of the circle? Yes. Now unit circle. So unit circle, we have the coordinates. So now we focus on the coordinates. The coordinates is x comma y. And the x is, because the r is 1, from here you can see x is cosine theta and y is sine theta. So x is cosine theta and the y is sine theta. So that is the coordinates. Now, how do we figure out all this? Okay, start with this point. Do you see this is a unit circle? Then the radius is 1, right? This length is 1. Then the coordinate of this point is 1, comma 0. Yes. And how about this point? Yes, 0, comma 1, this point. Negative 1, 0. And this point, 0, negative 1. Yes, everybody? Mm-hmm. And the origin is in the middle. Okay. Now, how about 30 degrees? For 30 degree cosine 30 degrees. Do you still remember last time we talked about two right triangles? One is 45 degrees. The other one is 30 degrees, 60 degrees. Yes. So the 45 degree, we have, this is 45 degree. And remember, 1, 1, what's the hypotenuse? 3, square root of 2. Yes, square root of 1 square plus 1 square. Square root of 2. And then we also talk about 30 degree. And then this one is 60 degree. So we have, this is what? 1. Then the hypotenuse is 2. And the other side is square root of 3. Okay, now look at this picture. The first coordinate is cosine. What's cosine 30 degree? That's 30 degree. Cosine is what? Adjacent, opposite, hypotenuse. What over what? Yeah, that's adjacent over hypotenuse. Yes, so you see the picture is square root of 3 over 2. That's the cosine. How about the sine? Sine of 30 degree is, yeah, opposite over the hypotenuse. That is why we get 1 over 2. Is that clear, everybody? Mm-hmm. Now, next angle, 45 degree. Okay, look at 45 degree. What's the cosine? Adjacent over hypotenuse. So 1 over square root of 2 is the same as square root of 2 over 2. Right, everybody? So if you rationalize the denominator, you get square root of 2 over 2. How about sine 45 degree? Opposite over hypotenuse. It's the same thing. Yes, everybody? So, yeah. You need to memorize the unit circle. And I'm teaching you how to get those numbers. Okay, everybody? So, let's continue. Okay, so next one, 60 degrees. 60 degrees right here. Cosine is what? Adjacent over hypotenuse. Yes, everybody? So 1 over 2. And then the sine theta. Sine theta is opposite over hypotenuse. Yes, so that's why square root of 3 over 2. So you figure out the first quadrant, these numbers. All good, everybody? Now, look at the second quadrant. Bless you. Do you see they have the same y? But your x's here, this x is negative of that. Yeah? Because they're symmetric with respect to the y-axis. So now you know this value and this value, the y is the same. The x, just put a minus sign in front of it. Yes, everybody? How about here? The y is the same, x put a negative in front of it. Here, y is the same, x is negative in front of that. So once you figure out the first quadrant, you can figure out the second quadrant. How about the third quadrant? See? From here to here, you have the same x, but your y is negative of that. So this point is symmetric to this point, right? So you put a negative in front of the y. How about this point? You look at this point, and you put a minus sign in front of the y. And this point, symmetric to this point, you put a negative in front of the y. Yes, everybody? So you take care of the third quadrant, the last one. What? So we have this one, okay? It's symmetric to this one. And do you see they have the same x? It's just the y. This is negative. So you put a minus sign in front of the y. And then here, same x, put a negative sign in front of the y. Here, same x, put the negative sign in front of the y. Okay, so this is how we find all the coordinates of the unit circle of the special angle. Next class, I will give you a unit circle sheet. You're gonna fill that out. So similar, if you don't get them all correct, you will come to my office to practice. So the unit circle, I suggest you print some copy and practice. Okay? So you fill with the degree, you fill with the radian, and then you fill out the coordinates. Okay, everybody? So print this out, practice at home. Next class, I'll give you this worksheet, and then you, yes, work on those. Okay, so have a nice day. If you have trouble with memorizing the numbers, come to see me in my office. Let's try to figure that out. Find the pattern. Bye.